Hi, I'm Mudinda and I'm here to help you understand maths better for free. Matriculants, this is our third video in our calculus video series. Make sure you've watched the first one and the second one. Today we're going to be looking at how to derive, or as I would usually say, how to derive normally, because we have been doing deriving, but we've just been using first principles. There's a much easier way to derive. You don't have to go through the long process of first principles, but you actually have to know that because sometimes they'll specifically ask you to derive using first principles. But today, we're going to be looking at the much simpler way to derive. Let's get into it through some illustrative examples. If you're given that f of x is equal to x squared, then the first derivative, f prime of x, is equal to 2x. What I've done there is I've taken this exponent of 2 and multiplied it by the coefficient there, which is 1. Then I've subtracted 1 from that exponent. This is how I ended up with 2x. And this is actually what we're going to do for every example. So if you're given that f of x is equal to x to the power of 3, then f prime of x is equal to 3x squared. You take the 3 multiplied by the coefficient of 1, and then you subtract 1 from that exponent. You always subtract 1 from it. If you're given that f of x, this is going to make more sense as we go along, but if you're given that f of x is equal to 3x to the power of 5, then f prime of x will be 15x to the power of 4. What do you think would be the first derivative of 2x cubed? Well, f prime of x would be 6x squared. So in other words, if I were to put this in a general formula, I would say whenever you're told that f of x is equal to some coefficient a, x, and some exponent n, then its first derivative would be n times a and x to the power of n minus 1. This is the more formal formula of how to derive, but you actually don't have to stress yourself or memorize it at all. It's actually just saying what we've been doing all along, that if you're given f of x, you take that exponent and you multiply it by the coefficient. Hence, you see here that f prime of x starts with n times a. Then you subtract 1 from that exponent, and hence you're seeing that n minus 1 there. So this is just the more formal way of recognizing the method to deriving normally. Let's look at some more examples together. So if you're given that f of x is equal to 15x squared, then f prime of x would be 30x. 2 times 15 is 30. 2 minus 1 is 1. If you're given that g of x is equal to negative 4x to the 5, then the first derivative g prime of x would be equal to negative 20 and x to the power of 4. Let's actually do one more here. What if you were given that f of x is equal to negative 3x to the power of 4? Well, then f prime of x would be negative 12 and x to the power of 3. We just take the exponent, multiply it by the coefficient, and subtract 1 from that exponent. That's how we derive. But what about when we just have that f of x is equal to x? How do we derive something like that? Well, the derivative of that is just 1. So whenever you're given just x, the first derivative is just 1. But why? Well, if you think about it, when you're given that f of x is equal to x, that means f of x is equal to x to the power of 1. It's just that the 1 is silent and we don't write it. Much like the 1 in the coefficient, it's silent and we don't write it. But remember, the rule to deriving says you're going to take that 1 multiplied by that 1. You're just going to get there 1. Then you're going to subtract 1 from the exponent, right? So you have 1 and x to the power of 0, because 1 minus 1 is 0. But we know from grade 10 that any number to the power of 0 is just 1. And so x to the 0 is just 1. So this is just 1 times 1, which is 1. And so that's why we say that whenever you're given just x, then the first derivative is 1. You don't have to show us these steps. If you're given just x, then the first derivative is 1. You can just write that as it is. Then what about a constant? What if I was told that f of x is a constant like 3? Well, in that case, f prime of x is just 0. So if you're told that p of x is 10, 10 is a constant, so p prime of x is just 0. If you're told t of x is equal to -3, -3 is a constant, so t prime of x is 0. Again, I won't just make you memorize this. Let's talk about why. Well, if I told you that f of x is equal to 3, would you agree with me that that's almost the same as 3 and x to the power of 0? The reason I'm saying it's the same is because x to the power of 0 is just 1. So 3 times 1 is just 3. So 3 and 3x to the 0 is the same thing. But if you have 3x to the 0, or maybe let me write it this way. Let me say this is the same as 3 and x to the 0. Right? It's the same thing because this is just 1 and 3 times 1 is the same as 3. So if you look at it in this way and you derive it like we usually do, you would say 0 times 3, but that's just 0, right? And then you'd say minus 1 there, so you have x to the minus 1. It really doesn't matter what this is. If you multiply anything by 0, the answer is just 0. And so f prime of x is equal to 0. And that's why we agree that the derivative of any constant is just 0. Okay. Let's look at some more examples. So, over here, we're being told that f of x is equal to x squared minus 3x to the 4. We're just going to apply the normal way of deriving to each of these. In other words, f prime of x would be equal to 2x minus 12x to the power of 3. So 2 times 1 is 2. We subtract 1 there, we're left with just 1. We do the same thing with this guy to get that minus 12x to the 3. Here's another example. G of x is equal to negative 4x cubed minus 12x squared. Well, that would mean that g prime of x is equal to negative 12x to the power of 2 minus 24x to the power of 1. I hope that makes sense. Here we have that p of x is equal to x cubed minus 3x minus 10. Well, you see, p prime of x would now be equal to 2x, and this one would be minus 3, because the first derivative of x is just 1, right? We said the derivative of x is always just 1, right? And then the derivative of a constant is 0, so we're not even going to write that. This is where it ends. Okay, so I'll just do a similar example there. If you had f of x is equal to 3x cubed minus 12x squared minus 2x minus 5, for example, then f prime of x there would be 9x squared minus 24x minus 2, and the 0 there, right? So I just forgot to mention as well that since we said that when you're deriving just x, the derivative is 1, that would mean that if you're deriving something like 4x, then the derivative would just be 4. Okay, you can think about this any way you want, but 1 times 4 is 4, and 1 minus 1 there is 0, so this is like 4 times x to the 0, which is 4 times 1, right, which is just 4. So if you have that g of x is equal to negative 4x, then g prime of x is just negative 4. It's almost like the 4 disappears there, and we explained why here. Okay, so if that's still confusing you a bit, just rewind this video, watch that again. But basically, whenever we're deriving just an x, we're left with just a 1. Again, and like I said, whenever we're deriving a constant, we're left with a 0. And so we're just applying these on all the little pieces of these longer questions. Let's look at some more examples. What about when we have something like x to the minus 3? We're going to treat it exactly like we've been treating all these questions. We're going to say f prime of x is negative 3 and x to the power of minus 4. Remember, minus 3 minus 1 is minus 4. Let's look at some more examples. If we had that g of x is equal to negative 2 x to the minus 4, then g prime of x would be equal to negative, oh, actually, it would be positive 8, right? Because minus 4 times minus 2 is positive 8. And x to the negative 5, because minus 4 minus 1 is negative 5. Now, if you had that f of x is equal to 1 over x, then you would want to first rewrite this as x to the power of minus 1. Now, we've covered this in our video on exponents, on the laws of exponents, but essentially you can always move something up or down the division line as long as you change the sign of its exponent. I want you to note that I haven't started deriving it. I've just rewritten f of x in a different form. Now that it's in a form that's a bit more understandable, I can find f prime of x, which would be minus 1 times 1, that's negative 1, and x to the power of negative 2. Now, this is a bit contested, but you may actually leave it here. But we know that in maths, and again, you would have seen this in our video on laws of exponents, we don't like to leave our answers with negative exponents. So we're going to go ahead and just move this back down to the denominator so that its exponent becomes positive. So f prime of x would be negative 1 over x squared. In a similar way, in this question here, I would first rewrite t of x as 3 and x to the minus 2. Now that it's in a form that's a bit more understandable, I'd start deriving it. So t prime of x would be negative 6 and x to the power of negative 3. And so t prime of x would be negative 6 over x to the power of positive 3, just to make sure it has a positive exponents there. Great, let's look at some more complex examples. So let's have a look here. We have here that f of x is equal to 3x to the 4 minus 2 over x squared minus 3x squared. So we're going to treat each of these elements and derive them as we normally would, okay? But as you can see, this guy here is not in the best shape, so maybe we'd want to move that x squared up, make it x to the negative 2. Remember, we can move variables up or down the division line as long as we change the sign of their exponents. So I'm going to actually rewrite f of x before deriving. So before getting to the f prime of x, I'll rewrite f of x as 3x to the 4 minus 2x to the minus 2 minus 3x squared. Okay? And then I'll start deriving. F prime of x is going to be 12x to the 3, right? Remember that times that and subtract 1 from the exponent, plus 4x to the minus 3 minus 6x to the 1. Okay, I'm done deriving, but since I have a negative exponent there, I'd like to just rewrite that as 4 over x to the positive 3 minus 6x. Okay, so this doesn't affect any deriving. I'm really just rewriting this in a more comfortable form. Great. This last example, you may find a bit tricky. You can pause the video and give it a try, but what's tricky about it is that you have over x there, and you don't really want to move that up. Okay, you don't really want to move that up because you're going to have something like x to the minus 1 multiplied by x to the 3 minus 2x to the 4 minus x squared. It's you can definitely work with that. It's just there's a much easier way to do a question like that. I would suggest that you rewrite f of x in the following way. You're going to rewrite it as x to the power of 3 over x minus 2x to the 4 over x minus x squared over x. You're completely allowed to do that because if you had something like this, you would take the lowest common denominator of x and just write it like that, right? So this is the exact same thing. But once you have it in that way, this x can cancel one of the x's, then you're left with x squared. This x can cancel one of the x's, and there you're left with x to the 3. This x cancels one of the x's in there, and you're left with x to the 1. Now take note, we haven't started deriving it. We're simply just simplifying and rewriting this in a form that's a bit more palatable, okay? So we have that f of x is equal to x squared minus 2x to the 3 minus x. Much more palatable, like we can work with this, right? Now we can start deriving with, say, f prime of x is equal to 2x minus 6x minus 1. Remember, the first derivative of x is just 1. Okay, so I hope this video has been helpful. Just a reminder that in the description box, I always put a link to the notes that we do in this video. So if you want to just revisit all of these or just have the notes with you for this video, you can find that in the description box below. I'll see you in part 4.